Hey class, I just want to cover a little bit more regarding MATLAB and gives you some additional code that you could look at, which will hopefully help with today's assignment that I showed. What I'm going to show today is how to write a function which will help to serve in a guessing game. And a guessing game, you might think of one that says, are you high or low or right on? So if I thought of a secret number, said, I'm thinking of a number between 0 and 100, and then you guess 50, let's say, and I'll tell you whether you're too high or you're too low or if you are just correct. Now numerically that's three choices: too high, too low, or correct, and I'm going to change those in this function to be a -1 if your guess is too low, a +1 if your guess is too high, and a 0 if your guess is correct. It's not going to be the most fun game. It'll be more like the game my daughter would play with us when we used to try to play Name That Tune, which is you think of a few bars and you hum them out, or you start to sing them, and then you try to have the other person guess. But whenever it was her turn, she would just say nothing but, what am I thinking of? And, so that'll be a little bit like our guessing game. So here on the screen is the matlab.mathworks.com site. I'm going to create a new function. A script would be very similar, something you could execute. A function is more modular in that it returns a value, and it has parameters that get passed into it, so it can encapsulate all the code there, whereas a script would have more global references, so anything could access it, and it's going to affect a lot more than just the things inside that file. So here's our function, the boilerplate code that comes up with it, standard apparently from this online editor. The function here and the end go together with the syntax. This first part in between the square brackets, output arg1, output arg2, that's saying that this function is going to return 2 arguments, and they're enclosed in this vector, which will have these 2 parts. So the first one, argument 1, second one, argument 2. And the name of the function is on the right of this assignment, called untitled2. We're going to change that real quickly. Input arg1 is the first argument to the function. Input arg2 is the second. So they're just trying to come up with some examples that we can look at to start with. And here's a little helpful note. This is how they do comments. They use the % to say this is the function, and here's where you can write down your comments about what it's supposed to do. So I'm going to get rid of this and start from scratch. I'm going to call our function, and what our function is going to be named is a match. I think that's what I'm going to call it, is a match. So the output variable, I'm going to call it is it. And the right side, the name is a match. I'll call it like this. So when I call this function later on, I'll write is a match like that to say, is this guess a match or not? So I write the name of the variable that's going to come into as guess. So whenever I call this function on the command line, it will get passed to guess. I'm going to write a little bit of a comment here to myself saying, is a match. This method takes an integer value, int 8, and returns well, let's write this different, just to be a little bit more precise with the way that MATLAB will do its help. Say, is it a integer value which takes on the following values? So here's the first one, negative. If guess is too low, 0 if guess matches the secret number, and 1 if guess is above the secret number. If guess is less than the secret number. Okay, so again, we're trying to find out whether or not you have guessed this secret number. So let's define our guess as well in this little part here. Guess an integer value of type int 8. So int 8 is going to be the data type, and that's going to be an 8-bit integer. And to make it a little bit more useful for our class, we'll make this a uint 8. So that's going to be an unsigned integer value type. You don't have to convert anything to unsigned integers, but we're going to talk about what that is just briefly. On the primer, I just want to talk about this. Some of the basic operations can be arithmetic, so you can add things arithmetically with arithmetic, plus, minus, multiplication. And there's also logical operators. And so the result of a logical operation would be a logical value. Is 5 less than 5? Is that true or false? It's false. It is not true. So that would be a logical 0. 5 plus 5, an arithmetic operation. So that's going to be the value 10. Oh, looks like I wrote that one wrong. So 5 plus 5 is 10. It's not 5. So some of the arithmetic operations, plus, minus, subtraction, addition, multiplication, division, exponent, so if you want to square a number like we were showing in class today. And the examples are showing A and B being just two different numbers that you could apply. So if A was 3 and B was 2, A plus B is 5. 3 to the second power is 9, things like that. Relational operators, those are going to be the less than or equal to, greater than or equal to, or equality. So we've been using the equal sign to assign values to variables. But if you want to check if a variable was actually equal to the same value, like we're going to do in our guessing game, is this guess actually the same value as the secret number we're trying to find? That is a different statement than saying assign some value to our secret number. So what I mean by that, let's go back here and assign a value to our secret number. So we haven't made our secret number here, but I'm going to make it here, secret number. And I'm going to make it a uint 8. So I'm going to say, I'd like to have a number of this data type. So it's going to be a strictly typed value here. And my secret number is going to be 5. So that's going to be the secret number that we're trying to guess. Now you can all see it because you can look at the source code, but the idea is you wouldn't be able to see the source code here. And so we're going to call it from down below. And then, is it? So is it here, we're going to set equal to false. So that means right now that you will never get this correct. I want to save it. I hit Control S. I can do it up here as well. We're going to save it and run it just so you can see that. I'm going to say save as, and I'm going to name this, and I'm going to name it the same as my function name. Doesn't have to be, but it certainly helps make things easier. So it's called isamatch back there, so I'm going to call this isamatch.m for a MATLAB file. Okay. So isamatch, I'm going to say, I'm going to put a value in here. I'm going to guess 10. And it's going to say 0 or logical 0, meaning false. I can put in anything here. 1,000 is always going to be false. And why is it always going to be false? Well, it's always going to be false because down here it says is it, is the value that's going to get returned. And there is no logic occurring. It just is always going to be false. I just overwrote this, I short-circuited it. So you can't change it. I can make it so it's always true by changing this to true. But what I want to do is adjust the value of is it to say, is it a match or not, by comparing the guess to the secret number. So if you recall earlier, if the guess is, and I have to use two equal signs, is equal to the secret number, that would mean that my is it would return true here. And to make it a little bit easier to read, I'm going to go ahead and put this in parentheses. Okay, it's not necessary because everything on the right-hand side, the equal sign, is evaluated at the same time. But just to read it, I'll put it both in parentheses there. And I'm going to do Control S to save it. And let's watch and see if, let's go right to the punch and see if I put 5 in here. Okay. So we're saying that 5 is equal to 5. That's great. Now the 5 that I input, just so you know, is not a U integer. It's not an unsigned integer. And I can tell what data type this 5 is by using this function called class. So if I write class, it's going to tell me what the data type is of the argument. So in this case, the argument is the number 5. It's going to tell me that it's a double. So a double means that in memory there are there's 8 bytes of memory used to figure out how many numbers that you can hold in this memory address. So the number 5, it's already in memory, and it takes up 8 bytes. So it's double, meaning it's twice the amount of a single. A single would have 4 bytes. In the programming primer, I spent a bit of time, let's see here, talking about different classes. Here's one where I say x is equal to 5. So I assign the value 5 to x. And if I want to look at what that class x is, it holds the value 5. It is a double. And in memory, it says down here that it takes up 8 bytes. An unsigned integer is an integer, meaning it has only whole numbers, and it's unsigned, so it has to be 0 or greater. And the 8, the uint 8, means that it has 8 bits. So each bit has 2 possible choices. That allows you 256 choices, 2 to the 8th. So you start at 0, and you go all the way up to 255. So if you have 255 numbers, 1 through 255 plus the 0, that gives you 256 values. Well, how can I tell what, if the value coming in is in fact what data type it is? Now let me first just show you a little bit about uint 8. So if I put uint 8 here, I put the number 20, it's going to give me a 20 back, saying, yep, that's allowed. It's going to take that 20 and it's going to pack into 1 byte of those choices. If I put a negative 20 in here, however, it's not allowed. There's no room for negative numbers. The lowest number we have is 0. The same goes for 256. Sorry, the highest number we have is 255. So it keeps everything clipped in this range here, which is helpful for your third question with the joystick to decimal as well. Now, how can I tell if a number is in fact, what the data type is? So I could say here, let's say x is equal to uint 8, 126. So I can look saying class x, and I'll say, hey, that's a data type of uint 8. But if I want to check just in general, there's another function, and you'll need it for your homework assignment, called isa. And what it does, it takes 2 arguments, and it's going to show you right down here on the screen. The data type is the second argument. The first one is the value that you want to check the data type of. So x, and I write down here with 1 single apostrophe, is it a uint 8? So if it returns true, that means it is. If it returns false, it means it's not. And we say, yes, it is true. Another option could be, of course, is it a double? No, it's not a double. The default value for anything, if you don't specifically set it, is going to be a double. So if I just wrote down 5 here, that would be a default. And so this will be true. 5 is in fact a double. All right, what does that mean for today? And what does it mean for your life here in this class? I need to check if this is a value or not, if it is a uint8 in your homework assignment tonight or this week. In this class, so we'll fictitiously do it. We'll say, let's make this actually be another number, NaN, that's a special number for MATLAB, but we could have picked -10 or 50 or something else. If yes is not a uint8. So let's do that case first. What we're going to do is we're going to check one after the other, after the other, after the other. And if we find our match, we will give the answer out as it. So let me tell you, on the MATLAB primer here, we're going to use something called an if-else statement. I'll jump forward a bit. Conditional statements. So this is going to be, you can look this up online as well in our Sakai class. There's just an if by itself, which would match with an and here. That would be the basic, simplest format that we could use. And saying if the condition to the right of the if statement, I'll fill it in here in a minute, is true, it's going to execute the things right after that line and before the next end. So execute the number of statements. There could be more than one. Anything in there, it would get evaluated. Otherwise, it just skips right to the end. So on the right hand, if this is true, I'm going to run this bit of code saying display, of course it is true. And if else, and if something is true, you run it. If not, you can have an else saying, okay, well then run everything else aside from that. On the right hand here, we have this, what we're going to do today. And if you check the first one, then you have a subcondition. Okay, wasn't that? Well, what if it could be this instead? And then finally, if it's not that, here's the third choice. Moving on to our bit of code. So let's run through it now. We'll check it in this order. If uint8, if is a, yes, we want to check to see if it is a uint8. We can do all of our stuff, and if it's not, we're going to say, and here's my end. I'm going to delete this, so hold on, don't worry, we'll bring it back. So if it is a uint8, that means we can do everything in here. We'll have our conditions. Conditions to check against the secret number. And otherwise, it is the wrong data type, so give it NaN value. And our value here is called is it. Is it is the what we want to return here. Is it equals NaN. Okay. Now we have to do our checks. So first check is if secret number is less than the guess. So the secret number is less than the guess. We're going to say is it is equal to -1, because I have it up here. Okay. Well, what else could be? Well, we have an else, but there's two different cases of else. Else it could be 0 or else it could be greater than. So we'll just do else if the secret number is greater than guess. By the way, you don't have to put these things into the parentheses. You can leave the parentheses off, but again, it makes it easier to read. So I'm going to leave them there. And you don't have to have it smack right up against there either. It can be out to the side. That's gonna be it. Okay, it doesn't like it still. It's got this little note here saying, hey, you're missing an end at the bottom. We'll fill that in shortly. Okay, so if it's greater than it is equal to +1. Okay, now I can say else if secret number is equal to guess. In which case I'm gonna say is equal to 0. And that's all I have left, so I'm gonna end it there. This isn't the most efficient code just yet, but it does everything that we want it to. So we can now test it. Let's run this bit of code to see if it in fact works like we say it is. So is a match. And let's guess 1. That should be false. Oh, the secret number is less than 1. Oh, I wrote my code backwards. I did a few different things actually. So the guess coming in has to be a uint 8. So here's my uint 8. I'm sorry, my uint 8. I'm going to call it this way. You don't have to worry about calling anything on your side. But it'll still oh yeah, I spelled it wrong. Okay. It is a match. So it gave me a +1. Well, that's not what I meant. I had wanted the secret number, if the secret number was less than the guess. And I think I was thinking that I said if the guess is less than the secret number. So I wrote this one backwards. My apologies for confusing you all. You saw that already, good tracking. And if the guess is greater than the secret number, I want to be a 1. So if guess is above the secret number, so here we are. So let's try this again. Uint 8, that should be a -1. Yep, and it is because it's less than our 5. Now let's go ahead and put in a 100. And that's going to be above our guess, which is a 5. And we'll put in a value of 0. Oh, well, I'm sorry, that's still the value of 5. That's our secret number. All right, so I get the value of 0 in response. So 0 in this case actually means it's going to be a match because that's going to help me to optimize if I'm too high or too low for this guessing game. And then let's just double check one more time. If I didn't put in if I got a value that was not an unsigned integer, and remember if I don't put in or don't explicitly state it to be an unsigned int, it will just become a double. And I get the right response back. I get a NaN value. So I can put in 5,000. Okay. So here's the code for this again. I'll show it on the screen for a minute. Kind of wrote down the pseudocode or just described what the function was supposed to do, the 2 arguments it took, the guess, and then the is-it being the value that comes back from it. When I ran the code with the 5 or the uint 8, that on the outside down here, this uint 8 here, when this is called on the command line or another place, this one here gets passed sort of like this through this door here to the method. And guessed is the variable that holds what was passed to it down the command line. So guess, when I run this code, holds the value uint 8 of 5. It comes down here, it creates a secret number, which we all see now as 5, stores it in the variable secret number. And now I want to do my check. Hey, was guess actually uint 8? If it was, I can do all this stuff right here. This is a nested if loop. You can see it nested, it's bracketed in a little bit. Otherwise, I do this part. This is my other case. Now, one thing about this, the secret number can be greater than, it can be less than, or it can be equal to. But because of this, there's only 3 choices. I split my world up essentially as fine as it can go. There's nothing else. After I say you're either above it or you're below it, there's only one other option, is the else case. So I could, if I want, just say, I'm gonna get rid of this part here and say, hey, you're either greater than the number, you're less than the number, otherwise you have to be equal. Just by definition, there's nothing else it could be. So this code will be nicer. So Linus, I'm sure he'd be like, yes, do it this way. And there are a couple other things that we could do if we wanted to as well to clean up our code. I'll show that here shortly, but let's just double check. Hey, does it still work? Yes, I still get my 5 as is. My 15 should be too high and my 1 should be too low. So what's one more thing we can check? Well, what we could do is set the value to NaN to begin with. And what I'm going to do here is, this is a nice thing to do because I can say, hey, at the very beginning, define a value for is it. So it's going to be NaN. So regardless of what happens, I have a value now that will be returned. And in this case, if it is not a UNT8, there's no code that gets run. There's no else condition. But I've handled it already before that function. I've said, okay, before it starts, I'm going to assign the value NaN, and if it's the input, this guess, is not the data type that I want, I spit out the NaN already. So let's go ahead and try this, see if it's a match of 5, and say, hey, it will not be that case. So just like earlier on when we said, hey, it's gonna be false no matter what, you're never gonna guess it right. That's kind of like what we're doing here, except we're following it up with code that will check later on. So it's just another way to clean up your code a little bit further, make it a little more concise. I'm not gonna be grading that kind of stuff, but just to show you this is what's going on with our if-else statements. So in your homework assignment, you should have everything you need to do that based on what I've shown today with the is a function in particular, the greater than or less than, equality, relational operators here, and how to assign values to respond. The other part, of course, is just how do can you do the math? Or, write down a piece of paper, how can we match up the 0 to 255 with what we think a voltage would be in there. And if you're having trouble with that, shoot me an email and we can cover it at office hours as well. Hopefully this helps, and I'll talk to you all on class next.